Okay, go straight to the extra practice. I want to get to exactly what you need to be doing in this. This is about similar figures. So we're not looking anymore, I'll get it up here in a second. We're not looking anymore at ident or congruent figures. Figures will be congruent, or similar, sorry. Different sizes. And I can't get this to work, so let's start the video. I'll take it up here in a second. So really what we want is to talk about proportions. Real quickly, that right there at the bottom, this is, oh, sorry. This bottom part here is called a statement of proportionality. This right here, the angles and the side lengths. So just real quickly so we get this, angle A is the same as angle D. Now these are congruent. Angles are congruent. Okay? So in similar figures, this is smaller than this one, angles are identical. Alright, so you have angle A and angle D are exactly the same. But the side lengths are different. You see that? Obviously one's smaller than the other one. Okay, but so remember, when you're talking about the angles, you say that they're congruent. When you're talking about the side lengths, you gotta write proportions. Proportions are two fractions set equal to each other. This is where students like to cross multiply, and you're gonna be doing cross multiplication today. Alright, so pretty simple stuff to do. So right here, we're putting all the proportions set equal to each other, all the ratios. So like DE, that's the same as AB. Okay, so DE is to AB as means equals, EF is to BC next. Oh, he's not here. Okay, so EF is to BC, and then they do the third side just because you want to know all the sides. FD is to CA, okay? Now the order isn't so much important. You could have said AC. It's the same segment, but try to keep everything the same as we do this. So these two things represent the statement of proportionality. So if they ask you to write a statement of proportionality, you got to talk about all their lengths, or all their angles, and all their lengths as proportions. Alright, so it'll mean a little bit more as we do extra practice stuff. Alright, let's take a look at this. Perimeters of similar polygons, areas. I'm going to show you these two theorems in the extra practice, okay? Let's go ahead and take a look at the first one here. The polygons are similar, find the value of x. Okay? So how do we set this up? We set this up as a proportion. Okay? So what you don't want to do is put them in the wrong positions. So like this is the top of this rectangle. Don't put it with this piece. You say, well, this is the top of this rectangle. Well, no, they have to look the same. So this is the shorter side, this is the longer side. So the shorter side must go with the shorter side over here. Does that make sense? So write your proportions just like that. 3 is to 2, as the longer side is to the longer side, 7 is to x. Do not mix these up. Do not do this. Everybody watch. Don't do this. Don't go from the big rectangle to the small one, and then the small one to the big one for the second ratio. You have to go the exact same direction each time. That's key. Otherwise, you're going to get the wrong answer. So now we cross multiply. So let's make sure we can all cross multiply correctly. Take 7 times 2, and that's 14. And then when you do the other cross, make sure you put the equal sign there. 3 times x. And now you solve the algebra portion, part of it. Divide by 3. Okay? So x equals 14/3. Okay? 3 is to 2, 7 is to x. 14/3 is 4 2/3. That sounds about right. 2, 3, 4 2/3, and 7. All right. So yeah, you're going to get fractions on some things, okay? But the point is, make sure you set these up correctly. Everybody do number 2, and tell me what x is. Let's see if you get it right. Now you want to pick up, this is upside down from each other. It's kind of difficult to make sure you get what you're looking at. So a single mark to a double mark, that's the side we're looking at, single to double. So 20 is to 8, you could have said 8 to 20, it doesn't matter which way you go. 20 is to 8, just stay consistent. So 20 is to 8, and then we need the x, that's a single to the triple, single to the triple. So x must go 25. So now we're doing 25 is to x. Make sure you go the same direction. Okay? Don't go 20 is to 8 and then x is to 25. That's backwards. Alright, and we cross multiply 20 times x, and then equals for the other cross, 8 times 25 is 200. Divide by 20. X is equal to 10. Who got 10? I know some of you didn't have time to finish. Did you set it up correctly is my main question. Okay. All right, let's go to the next step. Erase these. This is how your homework starts out, and then we start doing some different things. Let's talk about scale factor. This is key. This is very important that we get how to find the scale factor. Scale factor is just your a ratio, a fraction from one picture to another, and it's what you're multiplying by. So if I said, let's look at this one. Find the scale factor from A, B, C, D, E, the smaller picture to the bigger picture. Now they've set these up correctly. These match up. A is to K, B is to L, C is to M. So the order does matter here. That does help you. Okay, so what we want to know is, what did we do to this triangle to blow it up to this triangle? We're going from small to large. Okay, and that's key to understanding how to find the scale factor. So if you're going small to large, you should be multiplying by something bigger than 1. Because if I multiply, let's say I multiply by 1/2, doesn't that make the picture smaller by half? Half the size? Okay, so you have to use your brain here for a second. You want to go from small to large, so your fraction needs to be bigger than 1, meaning the top number is bigger than the smaller one. So all you have to do is find one side length and set it over the other side length. So if I went from small to large here and I did 2 to 3, and I said, oh, that's my scale factor. Well, you need to use your brain here. Is that bigger than 1 or less than 1? It's less than 1. So instead of doing 2 over 3, we actually say it's 3/2. We just flip it over. Okay? So whatever it takes for you to understand or how to get this ratio, scale factor, it's important that you get that. If I look at anything else on here, if I do the 1, these are both x's here. I could find x now if I wanted to. I could find y as well, depending on whatever the scale factor is. I can take the scale factor now and multiply it by any of these pieces to get those values. So to get x, I could take 3/2 times 1. Well, that means x is 3/2, doesn't it? 3/2 times this one, that's that x. Those x's should be the same. And to get y, I take 3/2 times 3 radical 2. Okay? And what does that give me? That gives me 9 square root of 2 over 2. That would be what y is. Write that down. Make sure you have that. How do you find pieces? By using the scale factor. That's what we do. You also can set a proportion if you want. So watch me. I'm going to do the proportion here in a second, so you're caught up. To show you that it worked. So our scale factor was 3/2, not 2/3. Right? You all good? We're going to get to the good stuff here in a minute. But you got to be able to do this. This is definitely on the homework check. I haven't made it yet, but I'm going to be asking you scale factor. I'm going to ask you to do cross multiplication, and then the other things I'm going to show you, okay? All right, so let me show you that this is actually right. Let's do a proportion the way we did the last two. Let's do 2:3 as, I guess write this over in 2, all done? Awesome. 2:3 as, what is the other proportion, other fraction? 2:3 if I want to solve for y. 2:3 as, what goes with y? 3 square root of 2 is to y. So small to large, small to large. 2:3 as 3 square root of 2 is to y. And look what happens when we do this. Watch. Here, we look up here. Cross multiply. 3 times 3 square root of 2. And 2 times y. So 3 times 3 square root of 2 equals 2 times y. We divide off the 2. That's what we have right here. So doing a proportion, you can also do that to solve the problem, or you can use the scale factor to get what you want. Sometimes you're going to have to use the scale factor because there's not enough information. Okay, depending on what it is we're doing. Typically you can do a proportion. But I require you to know how to do the scale factor, how to find it, and then how to use it. One, how do you find it? Set one side length over the other, and then ask yourself, am I going small to large? If I'm getting bigger, then I need to make sure my scale factor is bigger than 1. If I'm getting smaller, and they put arrows in the book, if I'm getting smaller, then I put the smaller number on top. Okay, think of it that way. If I'm getting larger, the larger number goes on top. If I'm getting smaller, the smaller number goes on top. Is that easy? For scale factor? Okay, good. All right. Let's go ahead and look at perimeter. Let's do some, actually, you know what I want to do? I want to do some problems out of the book for this next piece. Okay? So the first 8 or so problems are all the same thing we just did. Let's take a look at 9 and 10 here. And you can write this in the margins of your journal if you want. It says the black triangles are similar. Identify the type of segment shown in blue. So this segment is blue, that segment is blue. What do we call those? You guys remember what those are called? From a vertex perpendicular to the side. You know what that's called. It's called an altitude. Okay, so that would be an altitude. All right, and then down here, we have from the vertex down to the other side, but it's not hitting at 90 degrees. It's hitting at a midpoint. Okay? So this would be the mid segment that we're connecting there. Yeah. Thank you. Alright, so that would be called a mid segment. Alright, we're going to do these two. Ready? Set up a proportion. The altitudes are proportional just like the side lengths are. So we would say, if we're going to go big to small, x is to 16 as 27 is to 18. Okay? Everybody do that calculation. Cross multiply. Calculators. Calculator. Did you put your calculator back already? Anybody else over here? Calculator? All right. Everybody cross multiply real quickly. Let's see if you can do this correctly. Get 24? Make sure you can get it, okay? All right. This one's a little harder, so we're going to do this one together. All right. This is a 16, I do believe. Yeah, 16 and 18. All right. So you do the exact same thing here. Now this is going to be a little harder. So 16 is to y minus 1 as 18 is to y. Now watch what happens. Everybody write this down and watch what happens as we do this. Cross multiply. Doesn't matter which one you do first. 16y equals, and then 18 times this. It's not 18 times y. It's not 18 times 1. It's 18 times both of those. 18 times the y minus 1. That whole group. So you're going to have to distribute that through. Okay? So 16y is equal to 18y minus 18. Everybody solve that, please? Tell me what you get. Something like that. Oh, in the book? In the journal, 225. But this is out of the book right now. Okay, what'd you get? 9? Okay, so then make sure you answer what it says. Is find the value of the variable. So we did that, y is 9. If I wanted to know this length, you'd have to plug it back in. 9 minus 1, this would be 8. Okay. All right. That's not the biggest stuff I wanted to show you, but I did want to go through some of those problems with you. Let's keep going. Find the ratio of their perimeters. Now, the theorem that you were given at the beginning of your journal about perimeters is the perimeter ratios matches the ratios of your side lengths, and that's key. So, this is 14. A ratio that we have here, 8 is to 12. That's a side length ratio. That's going to be equal to the same ratio as their perimeters. Okay, so if I said I want to know the ratio of their perimeters, that would be pretty easy. I can get the perimeter of this one. If that's 14, this is 14. If that's 6, then this is 6. So what is this perimeter? What's the perimeter? Add them all up.
40.
40? So 6 and 6 is 12, 14 and 14 is 28, 12 and 28 is 40. Okay? So we went from, what did I say that was 8? Sorry. It's not showing up very well here. I'm sorry, it is 8. So that's going to make it 44. (16) and 28 is 44. Okay? So, we went from small to large, 8 to 12. So the side length ratio is equal to the perimeter ratio, the perimeter of the small to the perimeter of the large. I don't know what the perimeter of the large one is, but I can do cross multiplication to find the perimeter of this. Even though I don't know enough of this information, I can use this similar figure to get me that. That's the perimeter theorem that you're getting. Okay, so the ratio of the side lengths is equal to the ratio of their perimeters. All right, so everybody tell me what the perimeter of this is. Do the cross multiplication, please. What do we get, Anthony? 66. Yep, if you cross multiply, you get, so we've got 66. Alright, so we can do the cross multiplication. That's what I was waiting for. So now, find the ratio of their perimeters 44 to 66 would be the answer to this. Okay, that's the ratio of their perimeters. Whenever it says ratio, it means fraction. When it says proportion, this is a proportion. Okay? All right. Let's go down to this one. You all tell me, I want to know the perimeter of this. So you do the exact same thing here as you did up here. So you need to set up a proportion with the side lengths to the ratio of their perimeters. So let's see if you can do this. Fraction of their side lengths, identical to what you just did in the number 11. Your homework check is going to be taken straight from these problems. You want to make sure you take good notes. Done? Still working? Okay. This is the only side length here, so I'm not going to use that 36. I need to use this piece that matches that. So 18 is to 24 as, now you got to get these side lengths. But can we get these? Emily, what'd you do?
Well, I set it because I did 18 over 36.
Mm-hmm.
And then 24 over 8.
Okay. Do we have enough information? Anybody get the parameters? Who said yeah? How'd you get the parameters?
I put 18 over 24 and I put x over 36 and I cross multiplied and I divided
And what'd you get?
48.
That would be this piece.
Wait, which one are we talking about?
Perimeter would be the distance around here. Okay? Alright. So do we have enough information in these two? Not yet. Okay? So, let's come back to that in a minute. Keep that, everybody have that written down. Okay? What about area? Let's do the next set here. Now let's just do a worded part of this. This should be fairly simple to you. So, the perimeter of one polygon and the ratio of the corresponding side lengths are given. Find the perimeter of the other polygon. Same type of thing. So, the perimeter of the smaller figure is 48. That means I want the perimeter of the larger figure. Okay? So, this went small to large here. 2 is to 3. And the 48 is the smaller figure. So it goes on top here because it's the smaller one. Small to large, small to large. And then that's how you set that up to find the perimeter of the other figure. Okay? Down here, smaller one's 66. So it's the same type of thing. Look at this one. Larger polygon is 120. The ratio is 1 to 6, small to large. So here I'd set this up as 1 is to 6 as, this is the larger one. So this would go where? On top or bottom? On the bottom. So you got to match up how you're setting these up. Small to large, large to small. Make sure they're in the right positions. That's key to all of these. Otherwise, you're just doing cross multiplication. You don't even know if you're doing it right. Okay, and then you cross multiply that and solve that. Okay, I want to get to the area stuff real quick before we're out of time. And now I'll come back to that problem. Okay? 3 is to 6, and the area of the smaller one is 27. So here's how you do this. You set this up the exact same way, and this is your other theorem that's in the book. So I'm going to set up this, this ratio. 3 is to 6 as the area, this is the smaller one, so it goes on top, is to the other area. Now, this is not going to give you the same answer if you cross multiply now. Not going to give you the right answer. What you have to do for area is you have to square the side lengths. And then you cross multiply. Okay? So this would be 9 over 36 is to 27 over x. And if you cross multiply now, you will get the area of this figure, even though you don't have all the information. Okay, so let's do that. What's 27 times 36? 972. And divide off the 9. 108. 108 feet. And this is area, so it's squared. 108 feet squared. Okay? Everybody do number 20. Tell me what you get for the area here. Do it the exact same way. Find the area of that problem, of that figure. Square your side lengths only. Don't square the area. The area's already been squared. And then cross multiply. Here, let's get that. Got it? Okay, this is actually a pretty cool thing. So if you had similar figures, you could figure out perimeters of things, like really large things. Like if you had a model of a building you were doing, instead of going out and measuring around everything of the big building, you could use the model to calculate all that stuff. The square footage that you have in the building, you do by the model, because it's proportional to the whole thing, rather than going and actually doing the calculation of the big pictures. Okay? So this is a big deal. It's a good thing. All right. So you're going to be asked these questions tomorrow. Okay? Go back to this one down here that we were doing. We can't find the perimeter. There's not enough information. But we can find the ratio. The ratio of the perimeters matches the ratio of the side lengths. So that's a good thing until we can get some more information. And you can't, at this moment, you can't do it. But if I just wanted the ratio, which is really all it's asking up there, all I got to do is take 18 over 24 and then reduce it. You can leave it as that, but we don't leave our fractions unreduced. So the ratio of the perimeters would be the same thing as whatever this is reduced. Reduce them by 2, 3, how about 6? 3/4. So the ratio of the perimeters would be 3/4. In the book they write it like this: 3 is to 4. It doesn't matter, it's the same thing. Okay? Let's see if you can figure this out. We're running out of time. I've gone through some of your homework with you. I want to make sure that you can do these things. You know what? Let's do a scale factor one. Let's see if we remember this. Okay. Do this picture here. Find the scale factor from JKLM to EFGH. So we're getting bigger or smaller? What? Smaller. So if the scale factor is just a fraction. So is the top number bigger or smaller? Remember, it matches. If you're getting smaller, the smaller number goes on top. If you're getting bigger, the bigger number goes on top. So since he said we're getting smaller, get a fraction. Take any of your pictures together. If you don't know, you can do this. JK is to EF. So JK is 20. EF is 8, and reduce it. We can reduce this by 4, we get 5 halves. But remember, use your brain. You're getting smaller. So the scale factor says the smaller number needs to go on top. So really the scale factor for number 28 is going to be 2/5. Okay? Tips and tricks of how to get the right answer every time. But you got to practice. Okay? Next one, find the scale factor the other way. So what are you going to say it is? You're going from large to small. I'm sorry. Small to large. You're getting larger, so the larger number goes on top. Yeah, so you just put the 5 over 2. Right? Getting larger, so the larger number goes on top. Okay, and then finding the values, that's just doing cross multiplication. Okay, so if you wanted to know which set to do, what numbers to do, I would start at the beginning, start at 3, and then go through all these problems up through 34. Make sure you can do that stuff. Even the ones with the algebra problems that are in 37 and 38, make sure you can do those. So I'll give you 4 or 5 problems tomorrow to check some of the ones we may have already done. Okay? Alright, so you've seen how to do those problems.